afternoon to all of you. Well, I'm not really, the organizers, when they requested, they want me to talk on this particular Swachh Bharat session, but I'm not literally going to talk on Swachh Bharat mission. I'm going to talk on another mission called Clean Ganga mission. Basically, it is on how the space technology is helpful to in helping in creating awareness about the clean Ganga. So I'm not literally talking on Swachh Bharat, but it is a clean India. The clean India, clean Ganga is also part of a bigger part of this particular mission. So I would like to talk on the clean Ganga part. Well, this Ganga basin is known to everyone. How important is the basin, which is about 28% of country's landmass, and which encompasses 11 rivers, which is a transboundary in nature, which is traverses around 2,500 kilometers, which has got a 14 major tributaries, and which has about 43% of Indian population, and the rainfall varies from 39 to 200 centimeter, average rainfall being 110 centimeters. So let me come back to the issues. This particular basin has got a rapidly increasing population, rising standards of living, increased industrialization and urbanization is a major issue, and then there is a lot of sewage pollution due to industrial waste, sewage, organic waste, and also garbage, human dead bodies, animal carcasses. These all adds to the sewage problem, I mean the pollution problem in the river, and 0.9 point source pollution from the catchment areas, and there is also threat of global climate change and effect of glacial melt runoff on the Ganga flow. And as our coordinator, this consortium of IITs have been working and propagating Aviral Dhara and Nirmal Dhara. So this Aviral Dhara is a continuous flow. Basically, that is under threat because of the climate change. So how do we really address this? So Government of India has really launched a national mission for clean Ganga. That is the implementing wing of National Ganga River Basin Authority, but the overarching program is called Namami Gange. So we really look at it how this the current day modern technologies can really address this, how abating the how much can pollution can be abated, or whether would be able to monitor it, then how do we do it. To ensure the objectives of the whole NMCG is to effectively abatement of pollution and rejuvenate the Ganga. So in the past, probably this is not a new. When you go back in history, I mean 1980s onwards, there is an efforts, Ganga Action Plan 1, 2, several National River Coordination Program, Quality Program, River Quality Control Program, but they all have been done in a piecemeal. So now the government wants to try a holistic approach, entire the basin as an approach. This particular program differs from other as that they have been only trying to work on how much is sewage networking and how to control the pollution, to stop the industrial waste and as well as sewage waste. But now this program has been designed based on the holistic approach, the river basin approach, to maintain the minimum ecological fold and environmentally sustainable. So this is an interministerial inter-center state central coordination. We can see there are 8 ministries involved in it. Even you can gauge the fact that the present government has changed the name of the Ministry of Water Resources from Water Resources, River Development and Ganga Rejuvenation, to emphasize the fact that clean Ganga is an important agenda, a priority. They have renamed the entire ministry, and at the core is the Ministry of Water Resources, which we need inter-coordination from the various ministries, urban development, Ministry of Rural Development, several 8 ministries. So pollution abatement is a major thrust area, river development, riverfront development, ghat development is being done, then conservation of biodiversity, river entire catchment as well as the periphery of the river, a lot of afforestation programs you need to do it, and then capacity, how do you involve the stakeholders, how do you bring them, unless and until masses are been brought into the river quality control program, the program is not going to be successful. And then people's participation. So how are you bringing them into the program? And then there are a lot of monitoring activities. So this Namami Ganga program is a holistic approach that is about for 5 years from 2015-16 to 19-20, costing around 20,000 crore outlay has been already been allocated, includes ongoing projects and new initiatives, fourfold increase. Really the way it is the program implemented in the past, and now you can see the fourfold increase in the financial allocations. And primary focus is on the pollution abatement, moving from river clearing to river rejuvenation. This is the whole theme, buzzword of the whole program. So you can see the municipal sewage management. There are about 118 towns on the periphery of the Ganga. So that is the Ministry of Urban Development comes into picture. So you need to coordinate with them. So this 118 cities, how are the municipal waste? How do you reduce it? How do you treat them through, and then let the water to come to river? Then river surface cleaning, industrial pollution. There are about 690 very critically severe industrial pollution comes from those in critical industries. So how do you control? Zero discharge, zero effluent discharge from them. And then crematoria, connecting people with the river, quality monitoring. The TPCB has been monitoring at several places, but the monitoring quality will help you to how this river quality changes from time to time, and that will help you to devise the program. So that is where our space technology is coming into picture. So we thought we could do a great bit in that, in inputting our important critical inputs. Then biodiversity conservation, afforestation measures. There are bioremediation techniques are being talked about, innovative ways. You know, these weeds, but to certain extent bioremediation works, but bioremediation becomes invasive, it won't be able to help it. Then other concept, Aviral Ganga. So this is what I am just coming to our space technology support. So we have a water quality monitoring. So we have a aircraft, we have a satellite, several satellites keep coming. So with that, whether we'll be able to do quality, any kind of any, especially physical impurities, physical turbidity, color, and temperature. With the help of that, you can find out what is the quality. Then hydrological monitoring and evaluation. Then geomorphological monitoring of the evaluation of the river. And then we have a bioresource monitoring. As I said, the monitoring aquatic plant invasions, algal blooms, riparian vegetation, forest cover changes in the catchment, forest fragmentation and degradation, how it is happening in that. And a comprehensive geospatial database. For any, this Ganga, Namami Ganga program has a program called Ganga Knowledge Center. So we need to have a foundation database, so that entire database along with river quality data comes into picture, so that entire whole program is managed. So we have envisioned the space technology that we create a geospatial database like historical satellite data, high resolution imaging, multispectral imaging, aerial data, providing a contour up to 1 meter, and then map all the towns with the high resolution data, so that all the network is managed. So this is what the geospatial data is all about. Then water quality monitoring is that quality based assessment, water quality parameters. We have a turbidity, I will come to that aspect of it, and catchment delineation of the stretches. Whole Ganga is planned to divide into stretches and then treat stretches in a wholesome way, so that whole Ganga gets cleaned up. Then webcams, instrumentation tools, integrate them and integrate satellite communication, so that real-time water quality flows into that. And river restoration support, modeling studies, visualization. These are the few areas where we have envisioned for the entire whole program. I would like to cover that. Yeah, this is what portal we have done on our ISRO's Bhuvan portal. Entire Gangetic basin comprehensive database, be it on the land use land cover, be it on the soil, be it on the drainage network, be it on the urban sprawl, how the urban cities are growing, what is the soil, what is the forest resources, what are the drainage network, what are the canal. Every database of the Ganges has been at a very good resolution has been done. These are the so many layers of different scales have been ported. It's called Bhuvan Ganga portal. These are the basically essential for making a comprehensive plan for the Ganga. And then in addition to that, not only providing the geospatial data in terms of providing a portal, it is also application. Nowadays, mobile application for crowdsourcing. So what we have done is, we have developed our mobile apps, and so that all the the towns or villages located on the stems, they can use this and they can send the information where the Ganga is getting polluted, how the Ganga, what are the sources. This will come to the control center, and from there you can understand how the quality of the river is getting affected, then you can devise the schemes accordingly. So this has been developed, these about 1169 towns are there, and the panchayats are there, they are using these apps and providing the inputs. And this is how the input comes. You can see this mobile app, you have a sewerage network, and this is the picture of that. This information comes like that, flow. And this is what the app, in the presence of minister, this app was opened and the crowd is being used. And similarly, ghat construction, we have recently under development, because there is a lot of riverfront development is going on, and how this to monitor that ghat construction, a crowdsourcing or mobile application is being developed. And now just come to the picture, how the water quality from satellite data can be done. You can see the various water body status based upon the vegetation, based on the turbidity, based upon its quality status, it appears differently. You can see from dark blue to black to red. So these are basically because of sediment, because of vegetation. And you can see some more examples. Different static water bodies, there is how they appear based on the status of their quality, water quality parameter, they appear differently in satellite images. And so these are the basic 5 parameters from satellites we can calculate, that is total suspended solid, color dissolved organic matter, Secchi disk depth, chlorophyll and temperature. So these are the parameters at different we can see that we have a world view satellite, we have a Landsat satellite, and these parameters at different wavelengths where they are very sensitive to this particular parameter. So this satellite can give you these parameters. And we can see many all over the world, many satellites, we can say the green shows that very high probability that this very highly favorable. So many satellites are available which can be roped in to calculate on a periodic way, because unlike the static water bodies, the river flow water quality is dynamic in nature, continuously keeps changing. So for that you need a periodical monitoring, so we need to take the help of the many satellites for that. And you can see what we have done is a campaign. The most critically polluted stretch is from Kannauj to Kanpur, which is around 600 kilometers. So we have taken that as a priority area, and we have taken the satellites data, and we had a concurrent ground truth campaign. We go with a spectroradiometer to measure all these parameters, and then take a samples and collect it, and then try to correlate with the reflectance, and then map the entire quality of the river stretch during that particular period. You can see this, how the water quality of near Allahabad, Varanasi and Kanpur, how this water quality map, and these are some pictures of that, and how the quality mapping has been done from different dates. So this is from some stretch near Kanpur, and this is what our field campaign photographs it shows, field campaign. And then this is the basic curve we develop, and based on this curve we identify, we interpolate it, and then we try to use that to gauge entire, you can see this, you can fix it, the qualitative information to quantitative based upon this particular ground campaigns. And then also ISRO has tie up with American aircraft. Recently with NASA aircraft, hyperspectral radiometer, hyperspectral imager we have flown across, especially near Buxar, Bhagalpur and Howrah. So this is we are trying to understand how, because in literature shows that hyperspectral, because very narrow wavelength it provides, it is highly sensitive to water quality, certain water quality parameters what you can get from the broadband bands. So we have flown an aircraft with a special instrument to study the water quality, especially these stretches, and these are the photographs what we have collected. Ground campaign has been done when it was flown, and this is the spectra we obtained, and then this is the stretch of image of the river Buxar, and that is what we have done. So, but ultimately our interest is these are the water parameters which are being already generated. These are the around 13 stations which are continuously the water quality on every 15 minutes water quality is being generated by CPCB. That we wanted to integrate through a model like this, a simple model, a remote sensing based water quality and field measured water quality into using discharge and the geometry of the river. We wanted to generate a very generic water quality map on a periodic basis which gives you a common one can understand. So, now we are in a process of developing this kind of a very generic water quality map of the Ganga. So, so far we have implemented so many tasks, generation water quality periodically being done, a GIS database been done, mobile apps have been done which are helping them to quality information being gathered, and also the guards are being monitored, and these are some of the kiosks we wanted to establish. These are the comprehensive vision, but whereas the red ones are only where we are able to implement right now. We are in the stage of developing this other applications as well. So, this is what portal and a frequent monitoring and the constant water quality map and integrating the crowdsourced information, you can generate a very comprehensive water quality information. Thank you very much here.